Sometimes I don't finish class entirely, so here's a video showing some synthetic division. We are going to do the second problem here. I'm going to skip the first one. The second one is going to cover some more situations. It's more difficult, so we're going to do that. I'm going to try to bring up a whiteboard to write on, and that's the problem we're going to do. We're going to factor it, use synthetic division, then factor it all the way, even with imaginary numbers if needed. So let's see if I can get this to work. Continue. Okay. Hopefully, hopefully this is good. Um, hmm. All right. So Zoom changes every time I get into it, it seems. More tools. I want to move this thing up. Let me see if we can just there. Move it up that way. Okay. So we want to factor this 5-term polynomial. There might be other ways to do it, but synthetic is a good way to go. And the problem also told us that there were 2 roots already. So the roots that it gave us are -1 and 2, implying that x plus 1 and that x minus 2 are factors. 2 are factors. Okay, so let's do some synthetic division. I'm going to set up our box. We're going to bring down our coefficients. I'm going to check our powers are all in order: 4, 3, 2, 1, 0. So that's good. So a 1, a -1, a 2, a -4, and a -8. And it gives us these 2 roots, so we may as well use them. -1 seems easy to use. I'll start with -1. So right now we're factoring out x plus 1. Always try to keep track of what I'm doing as far as the root versus the factor. Drop the 1 down, multiply the -1 times the 1, and get -1. We're adding these 2 up, that's -2. We're multiplying -1 times -2, that's going to give us 2. We are adding those 2 up, that's going to give us 4. We're multiplying -1 times 4 and get -4. We're adding the -4 and -4, we're getting -8. We're multiplying -1 times -8, we're getting +8. And we do, in fact, get a 0 here, meaning that we've just factored out x plus 1. And we wind up with our answer here of 1x to the third, -2x squared, 4x minus 8. So that's representing a cubic polynomial. I'm going to stack this. I'm just going to do another division right here. And we're going to use the root 2 this time. So now we're factoring out x minus 2. Drop the 1 down again, multiply the 2, get a 2, add these 2 up, we get a 0. Multiply around, we get a 0. Add 4 and 0, we get 4. Multiply 2 and 4, we get 8. And we do get a remainder here of 0 again. So far we have factored our original polynomial, our 4th degree polynomial, into x plus 1 times x minus 2 times this one here represents x squared now, because this represented x to the 4th, this represented x to the 3rd, so this represents x squared. So this is x squared, 0x plus 4. Oh, okay. Is that part factorable? Well, it's not factorable in the world of real numbers, but we could think of it as x squared minus -4, and in which case it's a difference of squares. It would factor to x and x plus and minus, because it's a difference of squares. That's what the minus is doing there. And then we would have to take the square root of -4. So the square root of -4, square root of -4 is equal to 2i. So this is plus or minus 2i. So if we wanted this fully factored, we would still have the x plus 1 and the x minus 2. And we would have this fully factored in the world of imaginary numbers or complex numbers. This is complex factoring. complex factors. And our first answer over here would be real factors. Okay, so we factored that in a couple different ways using synthetic division. I hope that helps with homework and just another example. I got to figure out how to make this recording stop. It's amazing you get back to Zoom. It just changes so much in a couple months. All right. See you in class.